Okay, hello everyone. Welcome to our channel Code with Sunny, and today we'll be discussing the third problem of this weekly contest 299, which is maximum score of spliced array. Right. Okay, so this is a hard category problem. Yes, uh, there are some prerequisites like dynamic programming. Like if you have been gone to the discuss section, you can see a lot of people posting the Cadenius algorithm solution. Right. So in this video, I'm not talking about any Cadenius algorithm all. I will just prove it out how the answer will come and like what is the logic behind this swapping some subarray from nums1 to nums2 or vice versa, and how this prefix sum plays an important role while calculating this maximum possible score, right? So yeah, you need to have some basic knowledge of this dynamic programming. If you look out this related topics, you will find this, dynamic programming tag. Okay, so let's begin. So you are given a zero indexed integer arrays nums1 and nums2, both of length n, and you can choose two integers left and right. Zero, like, yeah, left should be less than or equal to right, and swap the subarray nums1 left with subarray of this one, right? You can choose two integers, this one, yeah. So you can swap any subarray from this nums1 with the subarray with nums2, and after doing that you may choose to apply the mentioned operation once or not do anything. So you can do for any one subarray from nums1, and you're not going to do anything and just keep nums1 and nums2 as it is, and our answer is the score of the arrays is the maximum of sum of nums1 and sum of nums2. Okay, so after doing at most one operation of this type, our new nums1 and new nums2, like it would be modified, our answer would be maximum of sum of nums1 and sum of nums2, and we need to return the maximum possible score that we can get after applying the above mentioned operation at most one time. Okay, so I will discuss all those examples in detail and also tell out the you know concepts in detail. First, let's look at the constraints. You can see max of n is 10 raised to the power 5. So it completely signifies that if you want like all test cases passed, you must write a solution in O of n time or O of n log n time, right? In the best possible case, like O of n square will not be get accepted. Okay, so let's move out to understand this problem in detail. Okay, so we have some nums1 array and we have nums2 array, right? So let's write down the elements as a1, a2, a3, a4 and a5. Suppose there exists exactly 5 elements in the first array, and b1, b2, b3, b4 and b5. Let the sum be s1 of this first array and s2 be the sum be the second one. Now you need to swap any one subarray from this nums1 with the same positions of the start and ending index of the chosen subarray with the nums2. Like suppose if you have chosen this one, then you need to swap this subarray a2 to a3 with the subarray from b2 to b3. So your new array would become a1, b2, b3, then a4, a5. Then you have the array second as a2, a3, b4, b5. So the new sum would be s1 dash and new sum would be s2 dash. Your current answer would be max of s1 dash and s2 dash. You need to maximize this answer by choosing any one suitable subarray, right? Also you yeah, like you cannot choose any subarray, then your answer would be max of s1 comma s2. Okay, you need to maximize your score. Now when I've seen this problem, like initially I thought of a binary search, but it all goes in vain because the answer is not no is and the like the answer that is not an increasing function or not nor it is a decreasing function. So what I thought is, why not to fix the end positions of the subarray being chosen and try to find out the most optimal left position. Like, okay, so what I'm talking about is, if you look out the answer as max of s1 comma s2. Okay, like you need to maximize the our your answer with s1 and s2, max of s1 and s2. Like the maximum will either come from s1 or it will come from s2, right? So what I had thought is, like, why not I should try to maximize this s1, sum s1, as far as possible by choosing the optimal index in nums1. Similarly, why not to maximize the sum s2 as far as you can by choosing the optimal index in nums1, right? And also, yes, you need to try out the every position starting from I equal to 1 and ending at I equal to n. Okay, so what I thought is, I will iterate in nums1. Okay, okay, so I will iterate in the nums1 and I will fix up every position, like first this position, then this position, then this one, then this one, then this one. And fixing up any position, let's call it at this position, I will just claim that what is the suitable subarray that ends at this position I, whose starting position is j, any position j, such that when we swap the subarray from j to I, from like bringing the subarray from j to I from nums2 to nums1, like swapping out the elements at the respective position within this range, then our new sum s1 dash would be s1 plus delta, and s2 dash will be s2 minus delta. Okay, where delta is nothing but what? Delta is nothing but the sum 2 from j to I minus sum 1 from j to I. Okay, like what does it mean? That if I will fix up any position I, then I will try to maximize the sum s1. So I need to choose some position j, such that on choosing that position j, we need to swap out the elements in range j to I from nums2 to nums1 and vice versa. Then our new sum s1 dash will always be incremented by this value delta. Now how this value delta will come? Delta is nothing but the chosen subarray. You need to increment your sum s1. So your delta would be sum 2 from j to I, like in the nums2, what is the sum in the range from j to I minus sum 1 in the range j to I. Okay, then if you are able to choose this suitable delta, then like suitable j such that delta is some positive quantity, then your sum s1 will increase and sum s2 will increase and s2 will decrease. Then your answer would be max of s1 dash and s2 dash, you will your current answer. Okay, so like let me take an example and show you how this will work. Suppose s1 is let's say 5 and s2 is, let's say, 7. Okay, now you have you are going to fix I over to this position and you need to find this suitable j, right? Suppose you have your j is up to this position and your nums2 is like j is also over to this position. So what is the sum in the range from j to I in nums1? So suppose the sum in the range from j to I in nums1 is coming out to be, let's say, 4. Let's call it as let's say n1 as 4 and n2 will be sum in the range j to I in nums2, let it be 10. Okay, now you are swapping out all the elements from this to this and you are bringing all this one to this one. Okay, so what is the change in this s1? Like what is the new sum s1? You can see the new sum s1 will always be n2 minus n1, which is nothing but delta. That is what I have written over here. Okay, and what is the new sum s2 dash? Will be negative of delta. You can see like s2 will be incremented by negative of delta, which is nothing but n1 minus n2. So this is our new sum. So if you are able to calculate S1 dash and S2 dash, then we can easily maximize your answer at the current position. Now the most optimal, like the most efficient ways to how to determine this delta efficiently. Like you don't know which value of J will help us to increment this S1 dash, like to maximize this S1 dash. Okay, now first I am trying to maximize this sum S1, then I will also maximize this sum S2, considering both as different cases. Okay, now if you look out my code, this part is for S1, like maximizing the sum for nums1, and this part is for maximizing the sum for nums2. I will discuss all those in detail. Now first understand how this will work. Okay, so as I have said, we have A1, A2, A3, A4, A5, and we have B1, B2, B3, B4, and B5. Okay, now you need to find you are maximizing the sum S1 such that S1 dash will be S1 plus delta, and S2 dash would be S2 minus delta. Suppose we want to maximize this S2 sum S2, then what I would write is S1 equals S1 dash equal to S1 minus delta, and S2 dash would be S2 plus delta. Since you are maximizing the S2 sum S2, we will choose delta such that we will try to maximize the sum S2. But now we are focusing on only one thing, which is sum S1. Now you can easily do for sum S2. Okay, so what I would do is I will try to fix one index, this I. Okay, now note that you would be fixing each index and then you will try to maximize your answer. So for the current position, let's say I am fixing this one. Okay, so you need to find some suitable G such that the difference which I am going to write sum, note that I am trying to write down delta, which is sum in nums2 in the range j to I minus sum in the sum 1 in the range from j to I. Okay, now you can see sum 2 can be written as prefix sum p2 at the position I minus prefix sum at prefix sum 2. Note that 2 is for the array 2 at the position j minus 1 minus, when you expand this one, it would become p1 of I plus p1 of j minus 1. Okay, so when you club the iths like I variables, you will get p2 of I minus p1 of I. Okay, and we will have a negative sign, and you will get p2 of j minus 1 minus p1 of j minus 1. Okay, now for the current position, ith position, you will always know the value of this one, p2 of I, prefix sum of I minus, like prefix sum for the second array at the ith position minus prefix sum for the first array at the ith position. You can easily calculate prefix sum. Okay, now how to choose this j variable such that this delta is maximized? Why I want delta to be maximized? Because we want S1 to be maximized, and for S1 to be maximized, S1 dash will be S1 plus delta, so I want delta to be maximized. Okay, so for delta to be maximized, this quantity is fixed, and we always know that this quantity, but what I want is this quantity should be minimized. Why this should be minimized? Because if this should be minimized, then only we can have delta to be maximized. So we want to choose some suitable G such that this delta is maximized. How to choose that some suitable G? Okay, now you can see there is something common over this term. Like if you choose some suitable G, this term would be, let's say G is 2, so P2 of 1 minus P1 of 1. So this is the second term written in this delta expression right over here. Okay, so you want this term to be minimized, P2 of j minus 1 minus P1 of j minus 1. So for every position of I, you want to find out the minimum value, minimum of, for all j which is less than I, such that P2 of j minus P2 of j minus P1 of G. You want to find the minimum value of for all j less than I, and the term is p2 of j minus p1 of j. If you are able to find this minimum value, you will subtract this minimum value for this from this fixed value p2 of I minus p1 of I, which is our delta. And if you have this delta, which is your the value, and it is maximized, you will increment your s1 by this delta, and s2 you will decrement s2 by this delta, because when you swap the subarray, your value, like your new sum1 will be incremented by this delta, and your new sum2 will be decremented by this delta. Note that you need to maximize delta because you need to maximize this value s1. Okay, and for maximizing this delta, you need to minimize this term, and this term is nothing but minimum value for all j which is less than I, such that p2 of j minus p1 of j is minimized. Okay, so you can easily keep track of this minimum value in a single variable also. Note that if a certain j does not exist for I equal to the very first position, you will take min value as 0, because you can take the entire prefix of the current ith position. Okay, so yes, so you are going to do this for every I from 1 to n. Note that you need to maintain this prefix sum variable for each array, so that we can you can easily find out the prefix sum at every ith position. Okay, note that you are going to maximize this s1 value sum for array 1, and note that you also need to maximize the sum for array 2. In that case, you can see the new sum s1 dash would be s1 minus delta when you are maximizing the sum s2. Okay, to maximize your answer also, and again s2 dash will be s2 plus delta. Okay, this sign will be reversed, minus and plus. Okay, so let's move out to the coding section to understand how this all can be implemented easily. Okay, so yeah, so let's calculate this sum1 and sum2, which is nothing but the sum of the initial arrays. Your min value will be 0, and prefix sum1 for the array 1 and prefix sum2 will be 0 for the array 2, and your initial answer when you are not going to swap any subarray from nums1 to the corresponding positions in num2, if you're not going to do any of the operations, your maximum score would be max of sum1 and sum2. Okay, now for this for loop, you can easily understand we are trying to maximize the score of s1. Okay, when you are trying to maximize the score of s1, then what is the new score we can get? Okay, so our current prefix sum at the ith position will be prefix sum1 and prefix sum2, and our delta would be prefix sum2 minus prefix sum1. Okay, minus this min value. This is what I have written over here. We know this value, but min value is not known, so we will try to find out suitable j such that for all j less than I, min of p2 of j minus p1 of j is minimized. Okay, so this is the min value. Note that at the end of this one, we are trying to update this min value with this one, prefix sum2 minus prefix sum1. So for each of the next possible I, we have the minimum value corresponding to any suitable j that will maximize our value as of sum1. Okay, so this one will be prefix sum2 minus prefix sum1 minus this min value. This is our delta. So since we need to maximize the sum1, so we will increment sum1 plus delta, which will be our new sum1, such that new sum1, and our new sum2 would be sum2 minus delta. So our current answer would be max of new sum1 and new sum2, and we need to maximize our answer with this value. Okay, note that we need to update the min value at each step, so that for next possible I, we would have the suitable min value. Like min value would be like for some j which is strictly less than I, min values will be the value which is minimum for all j less than I, and the term would be this one, p2 of j minus p1 of j. Okay, p2 of j minus p1 of j. Yes, now you need to do the same step, considering that you need to maximize this sum2. Since you need to maximize this sum2, you will write down sum2 plus delta. Now this delta term will also change. It will change like this one, prefix sum 1 minus prefix sum 2 minus this min value. And again you need to calculate the min value as prefix sum 1 minus prefix sum 2. You can finally return the answer. This will give you all test cases fast. Note that the time complexity is O of n and the space complexity is O of 1, because you are not maintaining any extra array. All we are doing is taking some variables in constant extra space. Okay. So if you guys have any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.